Welcome everyone. We'll get started in just a few seconds here as people log in. And hello everyone. We're very glad so many of you have joined us today to get an insider's view of the opportunities offered by Flight Operations Quality Assurance, or FOQA, for business aviation. No longer limited to the commercial and military aviation sector, the business aviation community can now take advantage of FOQA flight data and analysis to improve pilot performance and safety. To help us with this exploration, I'm joined by Dave Miner, General Manager of Business Aviation at Avidyne. The company's flexible and user-friendly avionics also gather data that can be used for FOQA programs. Also with us today is Charlie Precourt, Colonel, U.S. Air Force retired, and on the board of directors at the NBAA and EAA, and also the owner of Citation CJ1+. We'd like to extend a warm thanks to Avidyne, the sponsor of today's webinar. Now, I'm sure you'll have plenty of questions for Dave and Charlie, and we're going to get to those. All you have to do is type the questions into the webinar question section, and we'll address those towards the end of the webinar. First of all, though, I have a question for you. Let's get a sense for how widespread FOQA is in business aviation. And we're going to look at question 1 right now. Does your flight operation use FOQA, including regular analysis of the captured data? And just a yes or no question. So far, looking like majority is no, but still a good percentage are using FOQA. Right now, 63 to 37%. It's still holding steady, 63 to 37, 64, 36. So among our audience, it looks like most of the participants aren't using FOQA yet. Great. Now I'm going to hand it off to Dave Miner to get us started. Dave, over to you.
Hey, so just so you know, I've lost everything on my end, so I can't see you guys wave high or anything. So I just wanted to go into a little bit of how Avidyne actually got here with FOQA and the interesting parts of it. Charlie was an early adapter of the IFD installation in his CJ1+ as the FMS2. And during that installation, I had watched a YouTube video about, how pilots land the space shuttle. And knowing that Charlie was a space shuttle pilot, I was very, very excited to get to hear it firsthand how it was done. And he started describing how they use the Gulf Stream and all that sort of thing. And I was, of course, quizzing him very, very much because, coming in at 18,000 miles an hour with multiple engine failures kind of intrigued me. And he said, well, we would track the data, and then on our climb out, we would analyze the data. And he mentioned just in passing to me, he goes, it'd be interesting if we did that, if we had an easy way to do that in general aviation. And I told him that, the Avidyne does track that data. It is able to be extracted from the box, and maybe he could use some of that. And if you've never seen an Air Force fighter pilot, space shuttle driver, take a project from idea to this conversation, that's something you should really see. And so more eloquently than I ever could, I think Charlie can kind of go through that process.
Well, thanks. That's pretty nice of you, David, for the kind words. It is an interesting story with respect to the space shuttle. In particular, given that you don't have the opportunity to go around or the option to go around, every approach had to be as flawless as we could make them. And in order to be qualified to fly a first flight on a space shuttle, we had to have 1,000 practice approaches in the Gulfstream G2, which was a modified Gulfstream that could actually fly with the thrust reversers active on final approach to simulate the 20-degree dive angle that we had in the space shuttle. And so we would come down final at 300 knots indicated in that 20-degree dive, and we'd do a pre-flare at 2,000 feet. And then we would roll out on an interglide path to cross the threshold at about 230 knots and 30 feet above the threshold. Way different parameters than in a business aircraft or in general aviation aircraft, but nonetheless, it was a trajectory of parameters that we had to match in order to successfully land the space shuttle. And between each approach, we could do 10 approaches on a given training flight. The right seater was a safety pilot. He would grab the controls and climb it out while I awaited in the left seat a printout of how I performed on that previous flight. And it had a graphical depiction of my trajectory. It had a graphical depiction of my hand controller inputs on the stick, as well as a digital printout of how I did at various checkpoints along the approach. And then I could self-correct on the next approach. And so when I combine that thinking with what we know the airlines can do, which is they aggregate and de-identify all the data of all their pilots into a big database, and they look for trends. Trends in airspace management, trends in the way pilots fly the airplane, problems that can be solved before there's an accident. Thinking about both of those and how far technology has come with high-speed computing, lower cost electronics for our airframes, it just became natural that there could be something of high quality at low cost for general aviation to take advantage of. And sure enough, with the advent of some of these modern avionics and data transmission services, we're pretty darn close to a very low cost option. Business aircraft that do have FOQA today generally are airframes that came with a flight data recorder because they were commuter category and required it. But if they weren't in that category, to retrofit a flight data recorder is tens of thousands of dollars, way out of the reach of anybody who's operating a lesser capable aircraft as it's manufactured. So what occurs to us is now with opportunities that are much lower cost, there are things that can be done to make every flight safer by making every flight a training flight. What I'd like to do is, in keeping with a picture's worth 1,000 words, I have 3 charts that I'll throw up here to give you an idea of what we've done using the Avidyne in my airplane and some equipment that was off the shelf used in flight schools. We started to devise a pathway to be able to do FOQA and training on every flight. So this is kind of an intro slide here that basically says, with FOQA, if you can't measure it, you can't improve it. So affordable flight data monitoring for GA, in my case, and what we're doing to experiment with this is we used a device from AirSync, which talks to the Avidyne and collects a flight data log in my particular configuration. And then upon landing, we'll send that data by cell phone service to a server. And then from that server, it can go wherever I want it to go. And in this case, I asked it to go to Cloud Ahoy for them to analyze. Literally, by the time I shut the airplane down, everything you see on this page has happened, including on my app, on the phone, a printout of my trajectories and my scores, just like I had in the space shuttle. It's really amazing. So if we go to the next chart, I'll expand on each of the pieces of this. You can see the flight profile I flew as a practice flight in the upper left of that picture, but a little more close in view of the simple Avidyne box that is connected to the Avidyne. And then the app that I have on my phone, I can select any of the flights I've flown that appear in the app, click on them, and then go to debrief in Cloud Ahoy, and then get deeper into that data. So from a pilot interface standpoint, there's nothing extra to do. Go fly the airplane, come back, open your app, click on the flight you just flew, and there's the data. We, of course, have to work through what are the specific parameters that we want to monitor. Stabilized approaches are very, very important for those who fly business aircraft, particularly turbine business aircraft. But what we chose to do is to monitor things like the aircraft limits, gear and flap speeds during deployment, VMO, max speed on descent in particular. If you get too close to the maximum speed, this thing will give you a little grade that says you got really close to that. FAR limits, 250 below 10,000, 200 knots below a Class B. It can trigger to show you that. It can even trigger to show you something as simple, did you do a brake check when you left the chocks? And it'll just give you a little score at the end that says yes or no. And what was your max ground speed during taxi? Lots of things that just prompt you each flight to say, I didn't even notice that happened to me on the last flight. I'm going to watch closer next time. So it's a pretty neat little system that has a lot of promise for us. And if you go to the final chart, you can just kind of see in a little bit bigger expansion here. I just went out and flew what we would call a practice 6158 check ride. And that, the depiction in the debrief format shows the trace of all of the flight. I could click on the trace anywhere I want. It'll bring up data about that. And the scoring of that approach that I flew is in the upper right with the stabilized approach parameters. If I desire to look deeper, I can look at the actual trace of the glide slope, my lateral and vertical deviations, and so forth. And so all of this just comes right back to me within 5 minutes of landing with no pilot interaction required. So it's really showing a lot of promise. So where we think about FOQA in terms of translating from the way I described with the space shuttle and what we have seen it used in a much more expensive system with the airlines and in the military, people would ask, okay, so what does it take to actually claim that you have a FOQA system? FOQA is a voluntary safety system, and the FAA has levied no requirements on the minimum things you do. But what we did as a type club for the citation flyers is we created, as I mentioned, 3 categories of parameters that we thought were of interest to us. Our standard operating practices that do things like track a stabilized approach criteria, your operating limits of the aircraft, the maximum speeds for gear and flap deployment and other things, as well as the FARs that are of keen interest that pilot is in direct control of, speed below 10,000 and so forth, all like I mentioned. So we created our own list of things that we want to track. And when everybody participates in this, their data goes into a de-identified aggregated pool that will start to show trends in the community. And those trends could actually be things that we need to correct because of pilot technique, and SOPs can be modified. Or they could be trends in the airspace, like FAA wants to change a particular approach procedure because it will prevent flap over speeds, because they've seen in the trend data that those kinds of things are happening. So when the FAA gets involved in this, you can voluntarily send your de-identified data to the FAA, and they will use it for those purposes of improving air traffic control services. They don't use it for helping us in a type club improve how we fly, and it's not used for enforcement. It's used only in de-identified anonymous forms. So it's totally a voluntary program, opt-in, and yet for the individual, it makes every flight a training flight and makes people much more safe in the long run. So we think the opportunity is here. If you're interested in what the FAA says about it, they put out an advisory circular that's quite detailed. It's advisory circular 120-82, and it's all about FOQA. And it's, I think, worth your time if you're interested in a little more detail. Some of the barriers to entry, as I mentioned, are the costs and the equipment. Most of the airplanes that are out there didn't come readily equipped. Like Dave said, the Avidyne inside the avionics was already logging data. That's the way they designed it. The question was, how could we get it out? And how could we get it out with the pilot having to spend a lot of time personally downloading it on his computer and then mailing it off? And that was where the relay box for the AirSync came in. And then how could we analyze it? That's where an analyst that does things like this, like Cloud Ahoy does for flight schools, managed to turn this around in an automated fashion. And so the barriers of equipment and costs are starting to come down. And so I'm very excited about the progress that we're able to make and bring this, I think, a game-changing improvement to safety. The benefits to the individual in terms of making every flight a training flight become obvious. But then you can compare how your entire type club is doing and where particular types of airplanes have challenges. And then finally, and not least of all this, is the benefit for insurance rates. We've had a lot of discussions with underwriters who appreciate and recognize how this could be a game changer for them to qualify certain sectors of the aviation community as lower risk and individualize their assessments for things like insurance premiums. So we're pretty excited about that potential over time as well. So, Matt, I think that's probably enough from my standpoint as an intro to what we're able to do at this point in time, and happy to go to some questions.
Thanks, Charlie. And Dave, just to help the audience understand, the data that the AirSync is downloading is coming via Wi-Fi from the IFD, as I understand it, but the data that you can get is also dependent on what's available from the other avionics in the airplane. It's not just the IFD that's sending, well, it is sending the data. It's not just the IFD's captured data, but it's also the ProLine 21 data bus that's sending data to the IFD to send off to the AirSync, right?
So it varies by platform, varies by airframe. Basically, the data that's coming in is being captured and can be sent out. If you're in a limited type installation, say you're in an analog citation and doesn't have a lot of digital data coming in, then the IFD generated data is pretty much what you'd be looking at. Any air data computers that are tied in, which with RVSM being a long in the tooth thing now, digital air data is pretty typical in all of these aircraft. So that information is being brought in and transmitted out, as well as mode of flight and those sorts of things. So we have pretty good high resolution even in the most basic installations, but whenever you start getting into Primus and ProLine 21 type installations, the resolution becomes greater and greater and greater. So it's, as Charlie said, brake checks and those sorts of things can be picked up on digital data in certain platforms, and away you go. For us at Avidyne, we're, in Charlie's case, we were a slide-in replacement for a pre-existing piece of avionics. So it was an extremely simple thing for him to do, and he got a lot of side benefit and a lot of additional features that this type of aircraft and this group typically are clamoring for. So it was a win-win-win. And then when we started having the whole FOQA conversation in the early days, it just became a natural. It was just amazing for us.
And Matt, if I could, I'll pile on to that because your question is a really good one. I alluded to it a little bit earlier. Is the FAA doesn't say thou must have these parameters or you don't have a FOQA program. So put it on a spectrum where you are flying with ADS-B and you have a Stratus ADS-B in device and an iPad with ForeFlight or some other flight planning tool that does data logging on your iPad, you can actually get some pretty good fidelity with positioning and speed data right there. And on the other end of the spectrum is an airline that's tracking switch positions and configurations and all kinds of stuff. I mean, everything you could think of. So along that spectrum, you could create a FOQA program based on what you're able to get. But the interesting thing is, as these avionics become more adaptable, you find that there's more and more that you can actually access. So for a turbojet aircraft, where one of the more important parameters to monitor is stabilized approach, the nemesis for jets is excursions on runways, because they land too fast or they land too long and they end up with not enough runway for the braking capability. So what you can do if you have the parameters is you can, if you can feed those parameters, you get configuration, gear and flap speeds. You can get the pilot's targeted VREF speed is on the data parameters. You can get weight on wheels, so you know right where they touch down. And if you don't have those parameters, you can combine some algorithms of a whole bunch of other parameters to get pretty darn close estimates. So that's where this whole spectrum of what you can do with what you have is starting to become pretty intriguing, that you don't need as much as you might think to have a reasonable FOQA analysis capability.
So Dave, then what you're saying is you could really set this system up for any size airplane, it sounds like.
That's actually true. At Avidyne, we are looking at taking this from this high level and finding pilot benefits all the way down to the smallest airplanes. I have IFDs installed in my 172, and I can think of 1,000 ways that I could take advantage of something like this, even at my small level off my grass airstrip here at home. It's just, and that's what Avidyne's looking to do. Our whole focus on this is to make flight safety affordable, accessible, and easy to do. And I believe that we've met that criteria out of the box, and it's a fantastic thing.
So getting back to the actual flying, do you both have examples of where this kind of analysis has helped you improve your performance, where you've seen something that you weren't aware of?
I have personally, in some of those plots I showed you earlier, on one of my approaches, I had a late clearance for the approach, and so a late switch over from nav to approach mode, and had a slight overshoot of the final approach. But I was also changing frequencies at that time, and I was on autopilot, and I didn't even notice that it had overshot a little bit until I reviewed the data after the fact. More frequently, however, there are things like I've actually caught myself not making a brake check coming out of the chocks because of a radio call that distracted me, and taxiing down the long parallel taxiway thinking, did I make a brake check? And I made another one to make sure I had good brakes, because there have been situations where folks fail to make that brake check only to find out too late they don't have brakes. So, and then I always use it to check my taxi speed, and I'm recalibrating myself as to knowing by looking what my taxi speed is. Our SOP is to stay below 25 knots. And then more frequently for landing, I am training my eye better to know exactly what 50 feet at the threshold looks like. So the beauty of this is, just like I did on the space shuttle, I could fly the approach in the event of the approach as an example. I could fly that approach, and then I could, in my mind's eye, guesstimate what the data was going to tell me how I did. And then I could look at that data and correlate what I believed I had done with what actually happened, and then adjust my frame of reference on the next one. So that's what we're finding with those who are participating in this program, is when they think they're accommodating the SOPs and they realize when they review the data that they did, they kind of question, okay, what happened there? Then they go back the next time they fly it, they're looking at it a little more closely, and they actually come up with a tighter technique to stay within the SOPs. So I think everyone who has flown it will tell you that it's changed something in the way they fly, and they will, everyone I've talked to has felt that it's changed their thinking about it for the better. Feel like they're tighter on their own self-monitoring and so forth.
And Dave, have you been using it yourself that way as well?
So I don't have all the automation and everything to the level that Charlie does. I can look at it separately. And what it, initially for me, I live on a domed runway. One end's lower than the other, and it's grass, and there's no real approach or anything like that. It's a private field. Whenever I come in from the west, I typically land long, and come to find out it's because I'm high. And it's like Charlie said, he's training his eye to see what 50 feet over the threshold looks like. Well, my eye's good from one end, but it sure doesn't like the other end. So it was kind of interesting that I was like, huh, that information is there. So yeah, I mean, even at my low analog level, it's pretty neat.
It really is like having an instructor in the right seat, but one who is really precise at writing down exactly what they saw. And then at the same time, the data is private to you, because the individual, way you set this system up is, the individual is the only one to see the personalized result. The data that goes into the type club's aggregated data is de-identified. So, that it's a beauty of the way we're wanting to do FOQA, is it becomes a training tool for the individual while also being aggregated with type or safety of that particular type of operation, which is what the airlines focus on. They don't look at the individual unless there's really something of huge concern. They want the aggregated data for the fleet. We're wanting to do both on every flight for every individual. And you talk to airline pilots, a lot of them say, I've never seen the results of my data. I have no idea what it shows. Because unless something happened that was worth diving into for a deeper debrief, they don't bother with it. So this is going to be great for the individual from that standpoint.
That brings up a good point, Charlie. You have a good example of an airline that generated some data that helped the FAA revise a procedure.
Right.
And it wasn't the pilot's fault.
That's right. Exactly. It was a friend of mine who was at Northwest and became a safety vice president with them later in his career, and he found that they had an unusually large number of flap over speeds going into a certain airport on a certain runway approach. And they didn't correlate it just based on maintenance. They correlated it based on the FOQA data, where it all converged that this popped out. It was this airport, this runway, this approach, and the particular model of aircraft all came popping out at them. And they went and interviewed the pilots, say what was going on these approaches, and come to find out it was a design of the approach. The FAA looked at it with the airlines and said, yeah, we're going to fix that. We're going to give a further out turn on or whatever the fix was. But that's what the FAA wants to do with this stuff, is it wants it de-identified in an aggregated fashion to see trends that are repeated large numbers of the same kind of problem that they can go address and focus their resources on getting rid of those problems that keep happening. If you ever fly out of Van Nuys, that's a pretty challenging airport. And there are certain places on certain departures that can get people. And, of all the airports in the country, that's one that you see a lot of violations from. And it's this kind of data that can help the FAA, fix some of the designs of their airspace control.
So I can't help being curious. Did you get the feedback from the shuttle training flights in the Gulfstream as quickly as you get the feedback here with the cloud Ahoy system?
Yes. So we would fly an approach. So the typical profile was we would fly 10 dives, we called them, or approaches on a given mission, and each of them took about 7, 8, 10 minutes a piece, depending on the profile that you set up for. The first one, we would go all the way up to 30,000 feet, do the full spiral down. The subsequent ones, we'd only go to 20,000 feet and fly the base to final. But each time, as soon as you came and hit simulated touchdown, and the safety pilot took the airplane over for a go around to take you back out for the next one, while he was climbing out, the flight engineer would pull the charts off of the computer printer and hand them to you. And then the safety pilot who was observing and the flight engineer who was making calls, typically the right seater in the shuttle on a real mission would make altitude and speed calls for you while you were landing. In the case of the G2, the safety pilot wouldn't do that. He'd be watching for safety issues with the G2, and a flight engineer would make those calls. But the three of us debriefed during the climb out as to what we saw, what were the effects of the winds, how were your controller inputs, whatever the issue was that didn't make it as good as you wanted it to be, you could then go attack it again on the next one. And then they could throw in some malfunctions like speed brakes failed or whatever, and you critique the same way. So yeah, it was instantly available as soon as we got done. That made it the most valuable because you could fix it right there in real time. It wasn't 2 weeks later on your next flight.
So can you talk a little bit, Charlie, about the Citation Jet pilots? And they had a summit to talk about this subject earlier this year, right?
We did, and we had great participation. Textron hosted us in Wichita, and we had all the OEMs and the avionics manufacturers, some people who do flight data analysis, some people who do equipment retrofits. We all got together and talked about what are the barriers to entry, what are our options, and it was pretty intriguing because everyone was off looking at, okay, this is a challenge because these airplanes didn't come equipped. How can we retrofit in a very cost-effective way? We're still looking at a number of options from all of those piece parts to see how this is going to pan out. But the good news is that there are multiple pathways that all appear to be very executable. So.
And a lot of interest, clearly.
There really is. I think I would recommend to those who listen and have access to the NBAA website, there was a webinar like this that NBAA held back, I'm going to say it was August timeframe with folks from the underwriters industry. Jim Gardner, who runs the Aviation Industry Association, was one of the lead panelists. John Brogan from USAIG, and they talked about this. Without solicitation from us, they brought it up that we'd love to see general aviation get on a FOQA program of sorts. We don't want to particularly dive into the data with you. We would be overwhelmed because we insure so many different airplanes and the parameters would be so different. We want to know that you're on a system, it's reliable, it's feeding you accurate, reasonable data that can be fed into your training. And then from there, we believe it's going to be a game changer for safety and for insurance. It was really encouraging to hear that, because it's all the sectors of the community are starting to see there's potential here.
Great. So Dave, can you sort of summarize what Avidyne is looking at offering equipment wise to help people set up a FOQA system?
So that's the beautiful thing about Avidyne, is when the IFDs were initially designed, data logging was part of the baseline of the design. Probably at the time didn't really have a well, I can tell you for a fact, had no concept of FOQA being a thing or usable, or the data being usable for it or anything like that. But just serendipitously, here we are. We have it, it's usable, and it's high resolution enough that it's actually valuable in this up market that we're growing into. So for us, we just want if somebody wants to approach us to work on a program with us, we're open. We are not dedicated to any certain methodology or anything like that. We didn't have to do any modifications to our equipment to do this. So we want everybody to take advantage of it in any way that they can. Because like Charlie was saying, we believe that if pilots quit running off runways and fly safer, insurance will get cheaper for everybody, just as a natural fact. So, and if you can make flying cheaper, then there's more flying.
So from a equipment standpoint, they're really, I mean, it's kind of agnostic for the equipment, but if you have an IFD, depending on the type of airplane, it can not only, it captures a lot of data by itself, but it can also tie into the data bus on an existing avionics system to capture even more information, right?
Correct. So if you had, for example, in the small end, if you had an Aspen PFD and an Avidyne IFD, you'd have a pretty fully fleshed out data set of data to be able to use. If you had Garmin G5s coupled with an IFD or some other air data PFD AHRS combination that's out there in the world, we listen to all the data that's coming into the box and we transmit it in a way that's useful and what's the decodable. So yeah, I mean, all the way, like I said, Barron's 310s, my 172 with an Aspen in it. It's a whole group of data.
Very interesting.
There's a really good accident that the NTSB report. It's a case study. That's why it's good. It's not, accidents aren't good, but it's a good case study. Dale Earnhardt Jr.'s Latitude was in a runway overrun and they lost the airplane. Fortunately, everybody got out. Thank God. But it was a very classic textbook setup that led to an excursion. And of course, Textron's accident investigators were on scene with the NTSB, and what they noted is that they were able to quickly get initial readouts based on an SD card that was in the Garmin G5000 that had also data logging in it. And then that particular airplane, being commuter class, had a flight data recorder, and once they were able to access that, they could get even more. But again, back to my spectrum of what's available, avionics today are coming with data logging in them, so we ought to be able to take advantage of that. And then the more you can get off of the later advancements to come, where these avionics, like Dave was saying, whether it's an Aspen or a G5 or whatever it is that you're tied into, feeding and integrating these different boxes, they're all on a bus that's sharing all this data. If a box is doing logging and you can get the logging information, particularly by Wi-Fi, then it becomes really easy for GA to make this work.
That's a good point. Just to go over this again, but to make sure it's clear. So one of the easy ways to get that data is with this AirSync box, because it's just using Wi-Fi to communicate with the installed, like the IFD or whatever, if it's Wi-Fi capable. So there's really you don't have to like wire it in or anything like that, right?
That's, yeah, the limitations are what is on the Wi-Fi signal from the various avionics that it can talk to, and how many parameters are there, and how extensive and high fidelity the FOQA analysis you can do with that data. But yeah, that's the basics.
So let's go to our second poll question now. And then after that, we'll get into some questions from the audience. And here we are. What do you see as the primary benefit of FOQA? And multiple choice that allows our flight operation to find areas of improvement, helps incentivize pilots to adhere to SOPs, has a significant beneficial effect on insurance costs, or there's simply no way to improve performance unless there's measurement of the activity. And looks like the majority is answer number one, allows the flight operation to find areas of improvement. Second, we're looking at no way to improve unless you actually measure. And yep, looks like those percentages are holding. 65% allows us to improve the flight operation. 7% helps incentivize pilots to adhere to SOPs. 8% big benefit on insurance costs, and 19% no way to improve the activity unless it's measured. Thank you. So let's go ahead and look at some of the questions. The first one is, can you explain the difference between a FOQA program and an FDM or flight data monitoring program? Are they the same thing?
They are often used interchangeably. Flight data monitoring is the process of collecting the data. FOQA pretty much is something that takes that data and then does something unique with it that is applied to a larger group of aircraft. So you can do flight data monitoring on a single aircraft basis, and you can do your own trend monitoring of your own flying by yourself, but you're not going to learn anything about the fleet of other aircraft like yours. So where type clubs could come in and do FOQA, where they're gathering and de-identifying, anonymizing the data from all their members, and then you get, as an individual, to compare what you did through flight data monitoring of your airplane against a standard of the rest of your community. That's where FOQA comes in. Is you're now doing a quality assurance of flight operations. That's why the name comes more from the airlines, is because they're a locked-in community. They're a business. They have pilots that they're trained to their own standards, and they're salaried pilots, and they're expected to do the SOPs of that community. So flight data monitoring is in fact just the act of grabbing that data. It's what you do with it afterwards. It becomes the FOQA kind of system. And for GA, where none of us really, not many of us anyway, some people do 91K and they have flight departments, and they'd love to have this kind of equipment because their aircraft didn't come with flight data recorders either. But most of us don't have a boss that is a flight department guy, right? We are flying on our own. And if you're part of a type club that wants to gather together, or any group that wants to gather together, we have some folks in a part of the country that are already adapting to what we've done so far at CJP, and they're running off on their own. Is that they've got a 91K operation, and they're already doing their own thing with this because it's working for them. And they're ready to move faster than the rest of us in our organization. Fine, knock yourself out and go learn as you go. And as our system matures, we'll fold you back into the bigger group. But they have enough, they have a half a dozen pilots of their own. They're ready to start doing a FOQA for their own community of their own little team. Why not? It works. That I think is a distinction, is it's a group orientated look versus flight data monitoring is a capture of a single system. It's a capability to do so.
Excellent. So Dave, here's a question for you. Can you provide a cost figure to install the Avidyne system as a basis for making a decision on how practical it is to proceed, plus its ability to integrate to other FMS platforms? So I think when he says system, I think he means the FOQA system by itself, but also maybe, adding on top of that an IFD to be able to capture more data.
Right. So for Avidyne, our basis of FOQA, of course, is the IFD from the 410 all the way to the 550, and all of our variants in between. So depending on your type aircraft, depending on let's take a turbine aircraft example. Your installation for an IFD that's able to integrate and capture this data and transmit it out, you're anywhere between 45,000 and 120,000, depending on how many boxes you install, how integrated your installation is, all those sorts of things. So that's the window. Whereas, if you wanted to do a flight data recorder with a QAR on Charlie's airplane, it's $180,000 to $210,000. So, and you don't get a second FMS, you don't get ADS-B in, you don't get all those other great features, you don't get synthetic vision, you don't get all the things that we also add to the flight deck. So for us, it's more than FOQA, but if you wanted to comply with FOQA and get in on the all the benefits of that, it can be done very affordably.
So just looking at the AirSync box and Cloud Ahoy, you're talking about what, a few $100s a year maybe, or?
Yeah, that's what you can go on their websites and get an idea for their subscription services, and it's not a barrier for most to enter. And like Dave said, the avionics that feed those installations that come with data gathering, data logging already, the FOQA increment is not a cost. It's all the other things you get with the ability to do LPV approaches and get synthetic vision and advanced avionics capabilities. The FOQA just came with it because you have to get it off that device with these other peripheral capabilities and analyze it. That really isn't part of the concern once you have those modern avionics.
So Charlie, you're actually at a simulator training center right now.
I am, yeah.
Obviously on break, but
Yeah.
The question is, how do you translate FOQA data into action objectives for training?
Yes, and we are at CJP. We're talking about that very thing with flight safety text on aviation training, the flight safety simulator providers, and what we want to be able to do is a couple of things. We want to be able to take the aggregated data of our community by type of aircraft and look at the trends that seem to be challenging us in the kinds of flying that our members operate under. And then that can be fed to flight safety, and they can help us focus with scenario-based training and other emphasis areas. A couple of emphasis areas that you always get when you come to flight safety is things like wind shear and how to recover from wind shear, or stall training and how to recognize and recover from stalls. With the FOQA data, we are likely to identify some other things that are important to us, such as can we set up scenarios that lead to runway excursions based on the data we collect. So that would be a way to feed the aggregated data results to our simulator providers. On top of that, so as I mentioned earlier, the individual gets their own feedback. That individual can have his or her data aggregated over a course of 6 months or a year. How did I do as an individual on my particular operations? And that will show where I should probably focus a little more when I do go to the sim on certain areas. And that can be fed to our training providers too. So there's a couple of avenues: the aggregated fleet look at where the issues are, and then the individual areas for improvement for each individual pilot.
Thank you, Charlie. Dave, what does IFD stand for? Is it Integrated Flight Deck or Integrated Flight Display?
Integrated flight display. It's the name they came up with.
Okay, so basically that's the modern Avidyne GPS navigator with all the modern features.
Right. So for Avidyne, we have the IFD series, and we have our new Zeus-mounted Atlas series for larger jets, and we also have our Helios Zeus-mounted series for the helicopter market, turbine helicopter market. So all of these operate in the FOQA realm the same way, and we have GPS-only versions and also COM, nav, and GPS versions. So that's the integrated portion.
So question, does the Avidyne system, is it able to report to the FAA's ASIAS data database at all? Or, I mean, is that something you'd have to communicate to the FAA to set up?
So the ASIAS system is another voluntary system that any pilot could download the app, and just using the GPS locator on your cell phone, you could be uploading to ASIAS just that data that the phone gets, basically your positions and speeds throughout a flight. Very limited, but it's something. And the FAA aggregates that with every other airplane in the airspace to see trends in traffic flow and things of that nature. But they are also looking to be able to integrate more data like this, and they have a program called NGFID that the folks at North Dakota, University of North Dakota and their flight school have participated in, where they're actually taking data downloads as you would get from an AirSync, and using in their flight school operation the ability to upload that kind of data of higher fidelity than you'd get just your phone, with more parameters in it, going into an analysis system like that for the FAA as well. So there are a number of individual efforts around the country that are looking at that kind of thing, that any type club who is able to eventually get to their own ability to do FOQA could just take that aggregated data they collected and feed it by this advisory circular guidance into the FAA system, and it would become part of what you're referencing. There is the safety analysis of the airspace management, which is the FAA's focus on using the data. And it's all de-identified and so forth, anonymized. But yeah, that's coming, and ASIAS can start with as simple as, I got my phone, I've loaded the app, it's running while I'm flying, and the data of where I went, how fast I got there, and how high I flew is all they'll get out of that. But then it gets more sophisticated with more equipment.
Thank you. So Dave, question, is in the Avidyne system, are the recorded parameters user customizable?
No, it's all the data in is on the bus and captured and transmitted as it receives.
Okay, great, thank you.
I would add too another place, Matt, that I'm seeing this used more broadly now, that touches with the insurance underwriters, is the folks at Star Aviation Insurance have actually got an agreement now that is collecting data for those who rent Cirrus aircraft. And there's a premium reduction for those who rent aircraft for renter's insurance based on a willingness to provide this data that is captured in this kind of fashion for those aircraft operations. So expanding all the time as to how it might get used.
That's a good point, and I understand the way that STAR system works is you upload the data to STAR, and they can adjust your insurance accordingly, but also on a short-term basis too, so you don't have
That's
to.
right. That's right.
Be insured all the time. So here's another question. While it's a group-oriented tool, can you discuss the benefits to the single owner operator, like with Dave's 172?
Dave, you want to take that?
Yeah, so I actually had this conversation with a gentleman who owns a Citation, and he has 2 or 3 other people who fly it, sometimes for him, sometimes for themselves. And he has IFDs installed, of course, and he was extraordinarily interested in being able to track and identify how one of his younger pilots is actually flying, and how he's can actually judge himself. He has 3 different types of aircraft, and the Citation that he's in is his largest, and he feels that it's probably the one that he would most benefit from getting this type of information logged and captured in. So that's how he intends to use it. Spoken to other operations, flight schools and whatnot, and they just everybody sees kind of a different benefit that they can get out of it, but they're all looking at something in particular, and I haven't seen any two the same yet. So it's super interesting to us. Very early, but super interesting.
Yeah, some of those aircraft will have more parameters on the data bus that would be of interest to things like flight operations and maintenance. So, you know, if you can track touchdown, how firm touchdowns are and how fast tires are wearing out. I mean, you start to correlate all kinds of things based on big data and things that you won't see, you know, if you're seeing changes happen gradually over a long period of time with an airplane. Go back and look at the data and you see, well, this has been operated a little more roughly than other airplanes have. But this has potential to expand into a lot of other areas. If you put your airplane on a dry lease and you want to make sure that those who are leasing the airplane are working to the SOPs you expect, you're going to be able to see that. For the individual, again, the training benefit of every flight that comes right back to you with a parameter list that says, you know, you were red, yellow, green on each of these parameters: taxi speed, climb rates, speeds on descent, whatever it happens to be. A quick pop-up on your screen at the end of the flight says 1 through 25, you were all green, keep going. Or here's a red one, what happened? Click on it, go deeper, look at it and say, I didn't even know that happened. I better watch that next time. So huge benefit.
Excellent points. And I'm assuming there's also systems and engine data that's captured too, so that could be beneficial, right?
That's right. Yeah, it could go. So I'll give you an example. I have had an occasional glide slope alert, voice warning from my enhanced ground proximity warning system, and the avionics guys have chased it, and it happens just very rarely. And the most recent one happened at about 70 feet. Threshold crossing is at 50 feet. And when you're that low to the ground, it's supposed to self-inhibit to where it doesn't give that alert unless you suddenly were as much as 2 to 3 dots off. You know, I crossed the threshold at 45 feet. I was essentially right on, but it gave me a glide slope alert, and it's a nuisance. So they can't get other than what's in the self monitor of that box, what was going on. This data might be able to capture a whole bunch of other stuff that was on the data bus. It says it occurred at the same time that happened. That might be the issue. Go look. Whereas today, the maintenance guys can only get whatever got logged inside that box at the time. And there may be some additional benefits for getting aircraft off of AOG because you can look quicker at sources of the issues.
Interesting idea. Now, here's another interesting one. Rather than scrubbing and de-identifying the information, why not do the opposite? Why not use this as a way for positive reinforcement? Like if the pilot group in a small Part 91 company can go a year without unstabilized approaches, there's a monetary bonus, or allowing management to know who repeat offenders are so training can be more targeted.
That is also possible, and I like that. That's kind of the way I like to operate. But I will just say that there is a way to manage the data security such that it is anonymized when it's out to the world, and it's not anonymized when it's in your small flight department or your community that you're willing to compete with or share with. Like the small flight department I described earlier that had a half a dozen pilots. That's what they're doing. They get their individual data back. But if it goes out to a bigger group to be anonymized, and then it's going to go to the FAA for trend monitoring for airspace improvements, you would be able to do that anonymous while also having it individualized within a very small group of co-workers that are in your pilot group that you wanted to do that very thing. You can manage it both ways.
So yeah, that kind of segues into the next question, and that is, as a follow-up, I'm the FOQA gatekeeper, and what's the best approach to take when I see an event was triggered? I'd like to know more about the why of an event that was triggered rather than the what, and it's hard to do if the information is de-identified. But from what you're saying, you can share the specific information with the individual, right?
Yes, and what we're trying to set up, and this is still out in front of us, but what we would like in our system is that when I showed on the screen there earlier, the feedback I got on my app, at the top of a particular display, there would be a block that you could click for pilot input. So if something unique happened on a flight, I could put in there that approach maybe maintain 180 to the final approach fix. There was no way I was going to get down to VREF by 1,000 feet. I was just going to be late getting there. You can put that in there, and then that information can go, whether it's with the de-identified anonymized data or back with and stay with the individualized data. That comment can in fact go along with the data, even if it's a de-identified and anonymized, and it will get to the objective that the viewer was alluding to there, and you can get the best of both worlds.
So, and one thing that you're very strong on, Charlie, is that this is not just for landings, it's for all phases of flight, right?
That's right, that's correct. So as I mentioned, I'll just list off some of the parameters we've created through, kind of flight testing this and experimenting with it. We really like the idea of being able to check for that you did a brake check when you first started first movement. That's easy to check, and we like to monitor maximum taxi speed. We like to monitor climb and descent rates within 1,000 feet of level off. We like to monitor, VMO, MMO, the aircraft limits, the FAR limits of airspeed, maximum 250 below 10 and 200 underneath the Class B. So we have a list of about 25 parameters that run the gamut of an entire flight. Yeah, we put a lot of focus on the final approach because that's where the accident incident data says that's our nemesis. That's where we need to be as precise as we can with this data because it's likely to give us the biggest return on reduced accidents. But the whole flight's being looked at for sure.
Absolutely. And the is Avidyne going to have like a centralized place to find out more information about this?
Yeah, we have a Avidyne/FOQA microsite set up for information that's Avidyne specific. That's, as Charlie said, this is pretty early in the process. I can't believe, quite honestly, how fast he went from genesis of an idea to being able to have this full-bodied conversation. It's something else. But as far as getting data directly from Avidyne, yes, you can search the Avidyne website. We have a FOQA information page.
And so finally, let's discuss the important topic of security. People are always worried about, all this data being out there and who has access to it, and how are people protected when they participate in FOQA programs?
So they start out as they're opt-in, they're optional. Even the FAA says in their advisory circular they're optional. The FAA also says they don't want to see anybody participate in their analysis, their FAA's analysis, unless it's de-identified and anonymized data. So it has to be stripped. And then it comes down to a type club managing for the benefit of their members where the data is distributed and who is using it for what purposes. And that's something that each type club or each group, flight department, can determine on their own how they want to do that. But there are a number of ways to secure the data for the interest of the individuals. There have been questions regarding, can the FAA come after this? Well, if there's an accident or an incident, the ADS-B data of today has already given a tremendous amount of data. And so I like to think of this more of, this is data that's focused on a safety enhancement, and there are means by which it can be secured, and it's being requested to be anonymous when it goes outside of the enclosure of the group of users, and so those security systems are available to make sure that people are protected.
So something that I wanted to bring up along those lines, Charlie, is if you recall at the FOQA summit, the initial conversations were, this is going to allow data to get out there. This is going to allow the government to look over my shoulder. This is going to allow this, that, and a couple of other negative connotations. And that conversation ended very quickly whenever somebody just gently raised their hand and said, we're in an ADS-B world. If they want it, they already have it. So this is different. This is for our benefits. This is for our safety. This is for other ways to take advantage of information that's already out there anyways.
Yeah, I agree.
But technically, the owner of the airplane owns the data. That's fundamental, right?
That is, and that's why it's an opt-in program. That owner can make sure he has the assurances he or she needs to participate, and doesn't have to participate until they're satisfied with it. Those who bring options to the market for participation through equipment and analysis should bring with them those measures needed to assure that security.
Absolutely. Great. Well, we've run out of time today, and I'd like to thank everyone for participating and for Avidyne's sponsorship of today's event. And Dave and Charlie, thank you very much for a very interesting session today.
Thank you, Matt.
This
Great
webinar
job.
was recorded. Thank you. This webinar was recorded, and the recording will be shared with everyone tomorrow. And if we weren't able to get to your question, we'll follow up with a response. And I definitely learned a lot today, and I hope everyone else did too. Thank you very much, and have a great day, and good luck with your training, Charlie.
Thanks, Matt. I'm enjoying it.
All right, and happy birthday to all the Marines out there.
That'd be you, right, Dave?
Absolutely.
Yes, sir.
Very good.
All right, see ya.
Thank you.